Now in this question, we have to figure out about the unpaired electrons and low or high spin configuration. Okay, so the complex which is given is CO CN6 3-. First, let's figure out the oxidation number. We can easily figure that out as +3 here. And if I write the electronic configuration of CO3+, we'll get 3d6. Okay, now this is my 3d6 configuration here. But Cn- is a strong field ligand. Okay, so the pairing will happen here. Now these 5 d orbitals will split into T2g and Eg orbitals. Okay, here we will have dxy, dyz and dxz here, and dx square minus y square and dz square will be Eg, and they will be on top, like they will have higher energy. Okay, now when I have to fill all these 6 electrons, the first electron will go here, second will go here, third will go here, and then they'll start pairing up. Why? Because there is a strong field ligand here. Okay, so I'll pair all of these up. Okay, so all the 6 electrons will be at lower energy and they will be in T2g orbitals, which will be dxy, dyz and dxz. Okay, so that's why, because all the 6 electrons are at the lower energy level, so it will be a low spin complex. Okay, so whenever there is a strong field ligand, it will lead to a low spin complex. Okay, and as you can see here, all the electrons are paired, so there are no unpaired electrons and it is a low spin configuration, and that's how you can get your answer. So the first thing you will have to look for is whether there is a weak field ligand or a strong field ligand, and then there will be splitting. And after the splitting, in this case, because it was an octahedral configuration, or just because there was coordination number was 6 here, okay, it split into T2g and Eg, and then because there was a strong field ligand here, you'll have to pair it up, and then that's how you can solve this problem.